which is great. Howdy, everybody. How are you all doing today? Welcome to another Office Hours. Pull up the chat. If you're joining us from Twitter or from YouTube, or I guess X or YouTube or LinkedIn, howdy. Feel free to jump in the chat. I do have that pulled up. If you are interested, though, there is a link if you want to register for more of these. We try to do these weekly. We'll take some breaks now and then. Yeah, thanks for joining us. My name's Jeremy. I'm the Director of Developer Experience here at Synadia, and we maintain the NATS IO project. And so this is just a little fun weekly thing that we do where folks can hop in and ask questions, and we'll kind of cover just any recent news or blog articles or anything like that. I'm also going to go up into our NATS Slack and say that we are live. Tell us where you're from and what you're working on. I think today we're going to be bringing some folks up from the community to just chat about how they're using NATS, and we'll cover some recent blog posts as well. I'll read through some of them, and then we'll do a basic Q&A. So I'm going to jump in and say that we are live. So give me 1 second. I also have children. If you guys hear anything on my end, I have children home for the summer, so it's going to be interesting. But hopefully the mic works out well. All right, we are live. Join us for Office Hours. Yeah. Okay. Wonderful. Okay, Adam, thanks for joining. Alexander, Charles, Dan, is it Don? Ricardo, Shmel, and Stefan, thanks for joining us. If I'm pronouncing your name wrong, super sorry. Looks like Charles, you're coming in with a couple topics, which is great. We can chat about those. I'm gonna go ahead and share my screen, and we'll get into the agenda for today. Yeah, and so if you want me to just draw anything, or do some architecture diagrams, I love doing that stuff live, so we'll have some fun with it. Jacques, thanks for joining us on YouTube from South Africa. You're working on a vehicle tracking system. That's awesome. Jacques, we actually just got off, I just got off the phone. We're putting up a solutions page on Synadia right now about tracking vehicles. Or more just the overall use case of automotive, because we are working with a lot of automotive customers. So that's really cool. We'd love to hear more about that. I think that sounds awesome. Okay, so on the agenda for today, we're going to be, I'm going to be bringing up a community member, Don or Dan. He's going to correct me of what's the correct pronunciation. But we've been kind of running in the similar circles. I don't know why I put next here. I meant next, maybe auto-corrected. But we've been running in similar circles in the NAS community, specifically around Benthos. And I know there's also like new news around Benthos that would be interesting to cover as well. I know that's kind of popped up in the Synadia Slack channel, and folks might have some questions about that. Then we'll also talk about the NATS HTTP gateway, maybe even play with it for a little bit, and go over some blog posts that have been recently published. I'll read through some of them, and we'll just kind of chat a little bit about how that looks. And then, of course, all of this is here to service just a way to kind of ask questions and hopefully get some nice answers from some Synadians. So without further ado, Dan, if you are in the, I think you are in here. Give me 1 sec. Let's pull you in. If I know how to use Zoom properly, I'm going to go ahead and go over to participants. Let's see if I could pull you in. I'm going to promote you to a panelist. And then you should be able to share your audio and or video. Welcome to the show.
Yeah, thank you. Thank you.
Now, is it Dan or Don?
Well, you can call me anything you like, but usually it's Don.
Okay, I figured it was Don. Okay, nice to finally meet you in person, by the way. I know we've kind of been going back and forth with one another, so that's been fun. And so I met Don as an intro from the Benthos community first and foremost, but I know you've been playing a lot with NEX and NATS, and you've been doing a bunch of other just really cool things in general. So do you want to tell us a little bit about yourself and what you've been working on?
Yeah, so basically my background is in, well, basically starts like I think 14 years ago. Um, Around the time that the first papers of GCP and MapReduce and everything came out. And pretty early on, I decided that, yeah, basically everything in my organization is about events. So I started looking into Kafka, and I saw it mature and saw it go into, yeah, what it is today, basically. Um, but then a few years ago, I noticed this like NATS community, and I started looking into it, and it was really, really interesting. Mainly because yeah, you have different paradigms. You have back then there was no such thing as Jetstream. There were some things that were missing, like for example, one of the things that are very important to me, and I will explain a little bit, is that you have ordering in your messages and that
Mhm.
you have consumer groups and stuff like that. And back then there was nothing like that, or there was no way to simulate that either. So I had to like start a project on NAS, and then I had to migrate it back to Kafka because we were running into issues. But then, yeah, I mean, I kept following on with what was happening in NAS, and yeah, I think after my last startup, I basically said like, no, no, from now on, it's NAS all in.
Awesome.
So
Yeah, we've been
that's
we've been using an internal kind of moniker a little bit. You probably heard it leak out, but we've been using nothing but NATS, and I think the next team is really it loves using that phrase a lot. But we've seen that, right? Like I think NATS offers a bit of a paradigm shift in how a lot of these technologies look at the world, and we definitely have some interesting ideas, and they're not necessarily original. Like a lot of these ideas came from message oriented middleware from the
yeah.
90s, early 2000s, but like being able to have this kind of uh, I don't even know what's called, it's fabric or ocean, everything has access to and kind of floats around in. You can really build out a lot of it really offers a lot of kit for building applications, whether you want to do KV or streaming or microservices or anything like that.
Yeah, indeed. And for me, the most attractive part, and also the reason why I was so attracted to Kafka, was to have that like immutable log, to be able to make mistakes, go back and basically correct them because you kept track of your raw data, and you could just like migrate from that again. So obviously that is great. The reason why I love nuts and why I think there is nothing else that at this point can come close to it is because you have this notion of hierarchical streams. Um, the fact that you can make like, for example, in one of the projects that I'm working on right now, we have more than 3 million subjects. I mean, if you like, nobody in a sane mind would actually go on a Kafka cluster and create like 3 million topics. You don't do that. That's like, yeah, nobody does that.
No, 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 not at all.
And the fact that you can do that, and that you can do like selective filtering that happens on the server and not on the client and stuff like that, that's the stuff that makes a difference. That's what makes a difference between having to process for a few days because you're replaying something, and having to like just take the last messages and work on that. So yeah, we use it for really a lot of stuff.
That's awesome. Very, very cool. Yeah, that's something that I really appreciate about like Nat's consumer model. And I know I've covered this in one of my videos. And if you're interested in learning more about that, I have a whole video, like a 40-minute video on consumers. It covers why I think like Nats has this general superpower, which is like if you look at something like Kafka, that's like mainly an append-only log, and it's like really, really good at that. I'm actually going to just share my screen really quick, and I'll draw a little bit. You have something like Kafka, which is like an append-only log where and you're getting all these same benefits that you mentioned, Don, like where you have this it's very much what I mean by append only is it's immutable. You just keep
Yeah.
adding new items onto the log, and you don't really delete them. Like that's just not something that you do. And so you can kind of think of Kafka as like very simplistic in how it stores, its data, how it like ingests its messages. And this like allows you to have a lot of really awesome, throughput properties for your system. And so, it allows you to also do like crazy things like partition and manage those partitions. But what ends up happening is it also has a very simplistic model for when somebody wants to consume these messages, which can also be a challenge because if you like have a very large log, your clients are going to have to pretty much, for the most part, whip through that whole log in order to go and do things. And so, and that's not necessarily a bad thing if like that's what you want your architecture to be like. But what this results in is then, you have to essentially start like creating really start thinking hard about how you design your topics, right?
Yeah.
Because you can't expect clients to whip through everything. And so there's a lot of upfront design consideration that's needed there.
Yeah, and especially like the number of partitions that you're going to have, for example, like you cannot
Yep.
change it anymore because your partitioning is static. So
Yep.
that means if you're wrong, it has consequences to all the parallelism that you have in your system, in your architecture.
Mhm.
Um, and event-driven systems are not that trivial. Like once you get your head around it, it's pretty logical what's happening. But once you introduce things like, oh yeah, we have 3 different timestamps that you need to take into account. We have we have different ways how to consume and how to work around lag. Like these things are that's what makes like event-driven kind of hard. But
Mhm.
being able to say like, I know we made a mistake during our processing, but I can go back and I can reprocess everything. That
Yes.
would be that's super powerful. Now, bear in mind that the project that like the last project, the startup that I did, like we were aiming for a system that would store like 160 petabyte of data inside of Kafka. So
Yep.
it's not your usual use case. And many people basically said like you're a madman for doing that.
Yep.
But it worked. We could do things that other people simply could not do.
Wow.
And that is we even did reporting directly on NAS, on Kafka, because we figured out ways how to efficiently forward and backward consume from streams from topics. And that was like, yeah, I mean, people were pretty amazed of what we were doing just as being a relatively small startup.
Yeah. Yeah.
Yeah.
I think that's the cool thing with these enabling technologies. And that's honestly what I've seen too. Like one of the things I like to shoot, I keep sharing the wrong part of my screen. Pardon me, everybody, for the weirdness here. I'm still figuring out. Zoom recently changed some of their screen sharing things for webinars. Okay. There we go. We're back on the chart. So this is one of the things that I like to speak to a lot is like and we see this firsthand is like we have a lot of like organizations come to us at Synadia because somebody was using NATS. It was either like a single person or a small team, but they like moved mountains in an organization. They did something that like often would require large teams or like a bunch of engineering effort. And that's the cool thing about some of these technologies, especially like there's a lot of respect for the scale of what you can pull off with Kafka, with generally limited resources, with the right architecture. And we like to think of NATS in the same way, where you're able to go do something like really big and really impressive, with very little time, very little resources. And I think that's something that's really neat, and I love to kind of see a lot of. And so it's cool to hear that story is really similar for you. Um, kind of just to close up on this like consumer conversation, just for folks who don't know, and you can go watch the video, I explain this a bit more in depth. But something like Kafka would like really great for ingest and throughput, high scale, but you're kind of limited in terms of like what your clients can do. They basically receive everything. They have to whip through everything in the log. And I think what Don is mentioning here with NATS is like this idea that with NATS, a client has actually a lot more choice, or its consumer has a lot more choice over what it receives. And so it could have, I like to say that consumers are like windows into a NATS stream, where they have a lot of control over how they receive the messages, obviously the flow control of the messages, but also what messages they can filter down and receive, which makes NATS clients a little bit more or NATS consumers a bit more complicated in terms of their implementation for us, but for you, you have a lot of control, and then you can have a lot of these things coexist with each other. So we often recommend that, instead of trying to do a bunch of design up front of like, oh, how many streams do I need to create? Do I create like one per like tenant or whatever? Like usually when we start seeing like a lot of patterns, we recommend people put like more than you would expect into a single stream, because it's very easy to replicate these streams, to mux them, to demux them, to kind of compose them. And then your clients also have so many options available into how to efficiently over the wire, receive these messages. So it's cool that you've had that experience as well.
Yeah, and everything comes down with how you structure your subjects. Like, for
Mhm.
example, most of the stuff that we do is in the operational realm, which
Mhm.
means that you always talk about like business entities, like you have a
Yeah.
customer, and for that customer has orders, and every order has order lines. So what you do is you structure it in such a way that every entity basically has a part, and that part is your subject.
Mhm.
So that gives you great power for querying. While it isn't actually built for querying, well, it's a lot better than what you would have with Kafka, obviously, but you can put wildcards in and say like, oh, I don't know the customer ID, but I do know the order ID. So give me all the items for that specific order, or give me all the orders for that specific customer. So you can do, and all the changes to those orders, by the way, you can play with it, and that's super powerful. Um, that gives you like seriously superpowers when it comes to processing your data. Um, yeah,
Yeah, I've also noticed too, and what I've recommended for people, and maybe it's because I like working with folks who are doing stuff at the edge, but like this makes sense for like business entities. It also like works really well for like geographic distribution. So maybe another example would be um, that we have like a plant, a processing plant of some sort, and then we have kind of like a region ID. Um, and then in there we have like purchase orders or something like that, that are fulfilled. And you could really have a nice, event-driven architecture here, where this would might be like the actual like event name. And so one way to think about it is like your tokens kind of represent indexes of a sort. And
yeah,
there is a constraint around here, being that like this is hierarchical, right? This is not completely relational. It's actually like that, or it's not flexible in terms of its relations, but it's strictly hierarchical. Which means, like you said, it's not a SQL database. You can't query it like a SQL database. But if you craft your subjects in a way where you represent your business entities and your processes as things that are hierarchical, you actually get a lot of flexibility in terms of what you can get at. And I think it makes for a really good hybrid of this, like, you have this log of data that you're storing all of it, and it's very fast and efficient. But you
yeah.
you also don't have to whip through all of it like Kafka. You can get at it in interesting ways.
One of the other things, for example, that we're doing is we are control. So one of the side projects that I'm doing is I'm organizing, or I'm co-organizing or helping out with a summer camp. And during that summer camp, we have a lot of light controllers, so LED strings, like the lights that you have in your background, basically. But
Mm-hmm.
all of these have microcontrollers associated with it, and some of them need to be grouped together and need to change together. We even do this on stage with some groups that we're working with.
Mm-hmm.
But all of that is being driven through NATS. So we just say like, yeah, you can group your things together. You put them together in your subjects, and again, you're smart about how you do your subject mappings, and that's something super fun. Like we're doing DMX on top of NATS, like all of these fun things.
That's awesome. So how are those microcontrollers talking with NATS? Like what SDK are you using? Are you using the MQTT integration? Like how is that
No,
working
we
for you?
no, I wanted to use, so previously we looked into the MQTT one, but I didn't want to use the MQTT because I really hope to use Jetstream, because
Mhm.
for some things that like sending out heartbeats, for example, it would be very nice if they can just write directly into a key value store. Then I don't have to write an API, and I can just like have people listen on the key value store. But right now for MicroPython, which is the library and the programming environment that we're using on the microcontrollers, we don't have a decent Python library at the moment, MicroPython library. So we started building it well, we found some code online and we started tweaking it until it worked.
Hmm.
I have to say, like right now, it works really, really well. Um, I think the problems that we're having are more related to us being silly with it than, yeah, what we can
Oh,
do.
that's
I mean,
awesome.
it goes really, really fast. Um, and we can send over like whatever data that we like. So then
That's
the other side is one of the things that I wanted to do, because at some point I had a weekend off and I wrote the like a fuse driver for the object store. And the reason why I did that was I was so fed up using the tooling that I have for my microcontrollers that I wanted to just mount something on my microcontroller and change a file in the object store, and immediately it would be changed on my microcontrollers as well. Keep in mind, like these are like 100 microcontrollers or something. You don't want to go by and just reconfigure them all at once. I want them to reach out and get their configuration from somewhere. So that's yeah.
Oh, that's rad. Yeah, that's always been a pain is that microcontrollers like definitely don't have that same tooling that we're all used to for
Yeah.
managing like all these nodes. And so you're saying you have like 100-ish microcontrollers and you're using NATS KV somewhere inside of a
Well,
NATS
right
server.
now we use regular streams basically.
Okay, nice.
And the reason why is just because the Jetstream isn't implemented in the library that we're using.
Yes, I
Uh,
think I've come across that same library because I was also doing some MicroPython stuff, which by the way, like I also earlier today we just got off, a product, engineering priorities call and it's MicroPython is definitely something we've been talking more and more about, like supporting as an official
yeah,
library
that would be
because
really cool.
we get it comes up so often, right? I mean, we have the C library, we have the Rust library, but MicroPython for like microcontrollers would be really, really awesome. And so these things are connecting directly into a NAT server. And is that NAT server like is that in the cloud or is that like something running locally?
No, it's something that we have to run locally because our network connection that we have on site, this is literally in a forest, in the middle of a forest somewhere. Um, and the network connection that we have is pretty limited. So yeah, I mean, we have to do with what we can. Like there is a Wi-Fi network that we configure ourselves. I think last time there were around 82,000 LEDs. Uh,
Wow.
so yeah, the pictures are pretty nice, especially at night, where you have a lot of these yeah, light effects going on. But we want to make it interactive. So everybody who goes to one of these camps, they get like these badges. Like this is what one of them looks like. Yeah, I can't.
Oh, cool.
Come on.
Nice.
Yeah, we have people. Let me unblur it for a second. So that's one of them.
Hmm.
Uh, and we have several others that we created. Like every edition, every 2 years, we create new badges. But we want to make it interactive. We want to give people ways to interact with the lights. So, for example, if you come close, it will change in the color that your badge is configured in, and that like doing weird stuff with it. Like this edition, we will have a huge dome that will be addressed with LEDs as well. So you can play games on the edges of the dome and stuff like that. So
Wow, that's so cool. And so, I mean, I'm just curious about this now. Like, so what does like a subject hierarchy look like for something like this? You said there's like
um,
multiple groups, there's microcontrollers, that those microcontrollers have multiple LEDs. Um,
well,
it was
yeah,
like,
if you to be fair, we have been experimenting against the demo environment, the demo nuts environment. So the topics are still like the subjects are still there. Like
ah,
the ones that we have is, for example, we always begin with Area 3001, which because that's the hackerspace that I'm a member of.
Yep.
And then you have IRA, which is the device that we're talking about.
Mm-hmm.
There is the device group. So the member or the group that device is a member of. Like for
Mm-hmm.
example, the DOM, that would be DOM. Like you group everything together because then you can address them as a group as well. Like if you need to flash new firmware, you can
Mm-hmm.
just flash one in. Um, then you have device.
Mm-hmm.
So just yeah, we actually have the name device. So in between before we have the device identifier, because then you
Okay.
can like give me everything from device, because we also have some other things that we want to put next to devices.
Yep.
Um, and then after device there is outputs.
Mm-hmm.
And then you have an output identifier.
Mm-hmm.
And then you have what kind of protocol that you're going to send, which is RGB or DMX
Mm-hmm.
or yeah, whatever we want to support basically.
That's cool. Wow. And so that's kind of like what a message subject would look like, and then the payload is just kind of whatever that
Yeah, and
looks
then
like.
you have there are different subjects for configuring the devices. For example, instead of outputs, you would have config, and then you can configure the device and register new outputs or register different outputs or map them differently and stuff like that.
Oh, cool. Yeah. That's awesome. Very, very, very cool. Like and this is the kind of stuff, I mean, essentially what you've built is out of LEDs, you built kind of a little fleet management system, right? Where you have these microcontrollers that are running with all these LEDs, and you can, you can control all of these via streams. It's
Yeah.
interesting because we've seen this a lot in the wild. Like I'd like to say there's like four major patterns, and maybe we'll formalize this a little bit, but like four major patterns that I've um, for fleet, and I call this fleet management. The reason I call it fleet management is like it's not a fleet of cars necessarily, but it's like a fleet of devices. You have a bunch of these devices, and you need to do things with them. Um, and they're, they don't all live in the cloud. They live out in the physical world. They might have limited connectivity and stuff like that. But like, here's like four patterns that I've noticed with these is like, and it's funny because it kind of came up. As you were talking, like you have configuration management. You have like things that we want to do with these to update their config or even to update their software or to update their firmware, whatever. But you want to be able to, and a lot of people use KV stores for this. You want to be able to kind of tweak the settings. I know I have an example, and I think this will be my next video. I have a talk that I give about AI at the edge where I have this Jetson Orin Nano that's running like
Cool.
a YOLO, image detection algorithm, and I get to toggle between the different models. I even get to ship the model over like Object Store, which is cool, and I can change the tolerances and things like that. And obviously, like that's fun when you have one of them, but like it's actually so nice when you have a fleet of them and you start thinking about these groups and these different like models that you want to be able to have almost like a hierarchical configuration for. So config management is like one of them. And I know we're almost at time, and so I'll finish these. And I know Don, you need to hop off, but configuration management, metrics and monitoring. Um, the third one was remote commands, like I want to be able to go tell this thing to do something. And the last one, and I'm trying to remember this really, really quickly. I'll probably come up with the last one, but I know you said you had like a half hour and then you had to hop off. So, Don,
Oh,
this was super fun to have you on here. Oh, yeah, go ahead.
no, I've some time. I
Oh,
don't
you
mind.
do? Okay. I'm rushing myself for no reason then. So yeah, metrics was kind of this like second one that I noticed that it's nice to kind of get like, some form of telemetry. And this can be things that are just emitted via core NATS as an example, like advisories and stuff. But they could also be something that we push to a server. And the cool thing about stuff like leaf nodes and things you could do store and forward. So we actually do this with our customers. We're like inside of a vehicle and it's collecting telemetry data, and as soon as it gets its 5G signal, it's NATS is automatically syncing that up with the cloud. And so there's some really interesting things we can do there. The last one I'd say is live querying. where you're able to, and this is something that is really interesting with our service API is it kind of has this, there's no like service registry for NATS microservices or anything like that. They all just kind of respond to a subject. In a sense, NATS subscribe is like a service registry of sorts. But the ability to go across all your fleet and say, hey, give me everybody who identifies with this, and only the people who identify with that respond. That kind of live querying can really like help a large scale command and control style of this. And that's the stuff that I love is like if you're dealing with about 100 of these, you're going to want to figure out like, yeah, give me all the people in this group or give me all the people that
Yeah.
qualify with this output. And even if you can't shove all that information in an index somewhere, you can still do it by just asking the device, and I think that's a really, really neat pattern as well.
Yeah, and it is something that you see coming back in many places. Like one of the things that because you mentioned during the agenda also like next, it's even with next like where you basically put everything in. If you want to run something or you want to run a bundles execution, for example. Right now, if I write my applications, one of the first things that they do is basically call out and get their configuration from a KV store. So the
Yep.
only thing I need to configure is like, these are the NATS things that like my NATS credentials.
Mhm.
And then this is the store and the key where you need to get your configuration. And
Mhm.
then they would spin up and just launch themselves as a NATS microservice.
Yep.
That's it. Then I'm up and running and I can spawn as many as I like. And keeps on working. That's how I did the AI stuff here as well,
Yeah.
which was basically just I have Olama running here, which is like an LLM that you can run locally, or a library of LLMs that you can run locally. And I just spin up like a microservice that wraps that and expose it through NATS. And now anyone connected to that can make a request, and anyone can also contribute additional resources, like additional AIs or additional environments. And you get this sense of collaboratively performing tasks, or yeah, I don't know how you would call it, but it seems to work very well.
Yeah, yeah. So, and that's kind of the way we've been thinking about services for a long time, which I think really simplifies the stack in a lot of ways. Where like NATS is what you connect to essentially replace like the need for service discovery and DNS and things like that. Because as long as these apps connect in, then anything else connected to it, is able to talk to it. It doesn't matter where they live in the world. As long as all these NAT servers are connected into it, you now have this substrate that you're able to talk to. And so, like, let's say like you said, that Olama app that you have that might be subscribed on Llama dot, I don't know. I'm just going to call this like infer or complete. Let's say.
Yeah.
Um, and so these things all subscribe on that because they're going to be responding to it. And so then anything else can kind of call out to, they're going to call NATS request, let's say, Olama complete, and then they're going to give it, whatever stuff that they want. Send me, write me a description of yourself as an NAT service.
Yeah,
Bad
well, one of the
example.
things I use it for is to describe code, like generate me the documentation of this piece of code. And
Yeah.
then it just gives me back in Markdown what that code looks like. One of the things that is quite unique in the request response model that NATS has is that you can have multiple responses.
Yeah.
Like you're not bound to getting one single response back, which means that especially in when you're querying an LLM is always going to give you back like one, like it's sequential, right? He's predicting the next word basically.
Mhm.
But that means that he's giving you a stream of words, and you get that stream as a sense of responses back. And then once it is done, it waits for like 300 milliseconds or something, and then he knows that he has finished. So
Yeah, isn't that so cool? I thought about that as soon as like as soon as ChatGPT was like released, and I saw kind of what they were doing with like the web sockets and kind of doing that multiple, like streaming response back in real time. And I was like, man, this is like Nat's bread and butter right here is to
Yeah.
send back multiple responses until we've like closed out. And so it is such an interesting fit for LLMs for that kind of like real time communication. Because yeah, you're right. What ends up happening is this client ends up opening up an inbox reply, let's just say like inbox dot blah blah blah. And that's a subject that these folks are going to respond to, but it doesn't need to close out. That channel just remains opened. And so you can stream that response back, which is really, really cool.
Yeah, and
Um,
you also don't have to create, like in my case, the projects that I do are usually organizations that have stuff on-prem, they have stuff in the cloud, they have stuff everywhere.
yep.
But instead of having to spend like millions of meetings with security and infrastructure to figure out which firewall rules need to be opened, the only thing that I need to request is like make sure that I have access to your NATS cluster, and that's it.
Yes.
Uh, or to Synadia Cloud, and just let me work against that. And then that's enough. Like I can host my UIs, I can host my web UIs directly against the NATS cluster. I can host I can connect all my services directly to that NATS cluster. And I don't have to like deal with the problem of single sign-on or all of these things. Like it's all baked in. So I think it's a very powerful tool to build like a composite IT landscape in any organization,
Mhm.
not just the big ones, like even the smaller ones.
Yeah. I want to talk. Oh my gosh, there's so many things I want to talk about, but I want to talk about like, just because we're on the Olama like train here, and it's
Mhm.
kind of related to like here's one of the things that NATS is just like so fun with, is like this idea of kind of like federation, where like you said that you're running Olama like I don't know on your computer or something. Let's just say like this is like on Don's computer over here. Um, and you can hand me that binary and I could just run it on my computer too and connect into the same NATS cluster. And then maybe we have a couple of these that are just like on the cloud. And it really doesn't matter beyond like the latency. But like none of us are running reverse proxies. None of us are like,
Yeah.
running tunnels into the public internet. We're still behind our like own routers residentially, but we're hosting and participating in this kind of like federated like microservice. You say, give me all the services. And it's like, oh yeah, here are all the Olama services. And maybe we even have some metadata. It's like, here's where I live, here's where you live. Like, and that's like really cool when you think about it. And maybe, your architecture is not going to be like that for your for your actual like business, but thinking about how far you could stretch this makes for really interesting things, especially when you're like working at the edge.
Yeah, yeah.
Um, I,
Yeah,
I
and
think
also in some case, like for example, I just did the Wombat stuff, which was related to Bentos, right? So the whole thing about Wombat was that I needed to make a builder that was scalable. I needed to build binaries and people could request binaries, but I didn't want to like spend millions on cloud infrastructure. So basically what I did was just create a builder that is listening to a specific subject, well,
Mhm.
basically to the key value store. And then I can host it here on the same machine that Olama is running on. I can host it on a computer that is somewhere in my friend's place. But still, we can provide a decent service towards the community, which is quite nice.
So cool. It's so cool and makes for, I think, being able to distribute these things, being able to have this like hybrid model where maybe you have a service that is a cloud service, but self-hosting is now made so much easier. One of the challenges with generally the self-hosting communities is like, and I think Tailscale solved a lot of this now, which is it's
Mm.
really nice, but it used to be very difficult to just figure out, well, how do I want
Oh,
to
yeah.
securely, bring this stuff to the public internet? How do I want to be able to unlock my, my home, you know, front door from the cloud when I'm away or whatever. And I think that stuff, Tailscale obviously takes a very different approach, but NATS I think solves for this in a pretty interesting and novel way. We do have a couple questions that came up, and I think this will be fun to chat about. And Don, feel free to also just like jump in and answer these questions too. I don't have to be the only one answering them. If you are kind of here in the chat, I'm going to be pasting some questions, and we'll just like do our best to answer them. Charles, I know you asked a couple up front. We'll start with Jacques' question. It said, hi, if I want to store IoT data in Jetstream, is there a limit to the subjects I want to have and subjects like devices, blah, 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 blah. Is this a bad idea? I want to do this to later query the data. So like the thing that I think you have to think about is I think we do actually have a hard limit on the actual number of subjects. I can't remember, or number of tokens. I can't remember off the top of my head. It's something like 36 or something like that. But the actual limit that you need to care about is anytime that you are introducing like something with cardinality, that's going to obviously have an effect on memory usage. I can do as much back of the napkin math as I as I can, but the reality of it is I don't know how much data you're storing, how long you're retaining it, and what this looks like. Now the good news here is if you're doing something like year, month, day, you now have a generally bounded set of cardinality, and that makes it really easy to test with, right? And so if you absolutely needed to query, based on a day or based off of a month, like you totally could. Should you put the time stamp in there? Probably not, because that's going to introduce an unbounded cardinality, right?
Yeah.
Which means as your data set grows, your memory is just going to continue to inflate more and more and more and more. This will introduce some cardinality, but it's not a terrible idea. So, Don, what's your take?
Yeah, I think you're right. I mean, obviously, with the way how we're using it, we also have this unbounded problem. But I think the approach that we usually take is that the streams are facts, right? It's like something that happened. It is set in time, and it is a truth at that given moment in time. The only thing that you do is at that point you just listen to that stream, and you whatever application that you're building is interpreting those facts and making their own reality, or making their own interpretation of those facts. So I would, it's not wrong to keep it in there. I would maybe hash the year month date to have a little bit of less components in there, especially put a dot between the month and the date or something like that. Like you have to know that you can divide on tokens, or you can put wildcards in tokens, but you cannot do something like give me devices ID and give me these 3 years, like 2010, 2011, 2012. Those are 3 different subscribes that you have to do, because there is no way of getting all of those in one go. Or give me everything except for this. That's also something that you cannot do on it, because there is no regular expression or anything going on within the tokens when you're doing the filtering. So you have to be, you only have 2 wildcards that you can use, which is the I don't know how you call it in English.
You could just call it. I call it greater than. Yeah, your
the
catch-all wild card, right?
Yeah.
So
Yeah.
there's a token wild card, and then this one's a catch-all. It just gets that, takes the rest of the token or the rest of the subject.
Yeah, and that's also why like that structure, that subject structure is quite interesting, because this goes back to when we were doing big data structures as well. If you store something in S3, you would do something very similar. You would create like a folder devices with a folder ID for that specific device ID. You would put year first, because then you can basically say read everything under year, and that is my whole data set for that year. That might work pretty well, especially if you combine it with a key value store where you do some roll-ups for specific months and for specific years, for example. So for example, say, or even here, you can even do it over here, where you say like devices ID, and on the devices ID, you already store what the value is. And then devices ID year, you store the value of that year. and then under devices ID year, month, you store for that month. But you that way you can select what you want out of it without having to reconstruct all that data.
Yep. Yeah, and it goes without saying, I mean, if you have some historical stuff that you need to deal with, or real time, it doesn't necessarily fit with this model. It's also worth considering too that, like, messages are published at a certain time, and you can start a consumer at a certain time and you could stop it whenever you want. So if you want to be able to whip through and consume just a certain period of time for a certain device, like, you can do that. Consumers are, can be generally ephemeral, where you spin it up, you use it for what you need to, and then you tear it down. And that can also, fit a use case potentially. So there's a lot of options, which I think is really, really nice. It's just a matter of kind of learning which ones might fit for the use case best. Okay, I know we have about 13 minutes, so I'm going to jump into some of the other questions. Charles asked some at the beginning, so we'll go here. He says, I'm here for 2 notes/topics. First, is there a reference project that fully implements best practices for a Jetstream-backed job queue offering an RPC-esque interface? That's a great question, Charles. I don't think there is, but that would be that'd be a really good thing to implement, huh? I know we're working on reference architectures right now, and like, there's a desire on our part to kind of have like a way to say, here's like a reference architecture for this, and like, here's the Docker Compose file with it, with like, some of the code written and the like clusters set up and with auth set up, so you can just like spin it up and poke at it. And so, we're going to be working on more of those. I do have kind of my video on job queues, but I didn't write like a, service in front of it. You absolutely could write a service in front of it, which is pretty cool. And even if you do write a service in front of it, you actually can like enable, if you know what you're doing, you can enable even more functionality through that. So like, as of right now, there's no way to like send a work into the queue with a delay, right? It's always immediately delivered. But you can, in some ways, like send something into the queue and immediately consume it with your service and then put a delay on it. That's a workaround for something that needs to be in the server sooner rather than later. But like, there's a lot of interesting things that you could do when you kind of put a service layer in front of it that can give you the job queue that you want without it just being like raw Jetstream and you have to interact with that directly. So Alexander also said, like, a reference architecture for store and forward with leaf nodes would be awesome. Events up, keys down. Yeah. Okay. Well, that kind of gets us in, and Charles, I'll get to your second question as well. But I do want to talk to Alexander's question because I feel like I could draw something neat. Can you put a little bit more detail around streams, mirrors, sources for leaf nodes, store and forward use case? Yeah, so let's talk about it. And obviously the devil's in the details here. I agree that there will be a reference architecture because we do it all the time. We just need to do a better job documenting it. But let's talk about like leaf nodes for a second and how store and forward works, because this is actually really cool. So imagine for a second that you have like a centralized NATS cluster in the cloud. Maybe it's like this hub and spoke topology. It doesn't have to be, but like this, for sake of simplicity, this is what it probably is for most folks, is where you're going to have something in the cloud, and these are all your NAT servers, and they're connected together. And then you also have a leaf node, and this could be, a retail store. This could be connected vehicle, like a car. This could be if Don wanted to take his LED show on the road, and now he's running multiple summer camps, and now instead of just 100 microcontrollers connected to one summer camp, he now has 100 microcontrollers here, 100 microcontrollers there, and they want to operate independently, but they also might have some other stuff like telemetry data, other metrics and insights that Don wants to collect in the cloud and analyze later. And so just kind of stretching this use case a little bit more, we'll just say store and forward LEDs. We can let's just call this summer camp A. If I can type, and then this one will be summer camp B. And hopefully everybody will kind of understand my my reasoning here. So the idea here, and Alexander, you mentioned kind of like it would be like events up, keys down, which is kind of cool. I'm going to reverse it because I think for this with this one, it actually makes a lot more sense. Where actually no, I think I know what you're saying. Yep. So the idea here is like, let's say we're going to have some key value stores in the cloud because maybe we want to be able to configure all of these things in the cloud. And so we have our 3-node NATS cluster, and this is a KV store that maybe has configuration for all of these different fleets. And like Don mentioned, you could absolutely just use subject hierarchies, even in KV stores, to do things like, device, the group, the device type. You have all these things that you can key off of. And then all of the little microcontrollers might be listening on subjects, or KV stores for these. But the thing is, since these summer camps are in the middle of nowhere, maybe they have very limited connectivity to the actual cloud. Maybe there is some 5G radio somewhere that maybe like comes on once every 20 minutes. I don't know. Maybe they're running off of satellite, right? So maybe as soon as like the satellites come overhead, they connect to Starlink and do their thing, but that's going to be kind of iffy. So the idea here is we want to be able to take a configuration like this. We want to still configure it in the cloud, but we want to configure it in the cloud and be like, cool, just send it whenever you can. And so that's an example of kind of keys down that Alexander's saying, where you can tell NATS to create a mirror of these key value stores. You could create a mirror, and that would be like a one-to-one like digital twin of these. Now, the interesting thing is if you use something like a mirror, it is a one-to-one digital twin, but we have Summer Camp A and Summer Camp B, and maybe these things are completely unrelated to each other. We still want to manage them in the cloud, but like there's no overlap between the devices and what they do. So we actually want to like take this KV and we want to kind of like split it in half, right? And you can do that with sourcing. So instead of mirroring and giving a one-to-one copy, I want to source on this stream, and I want to source by saying I want like a filter that's like devices, dot like camp A or whatever. Maybe there's some geographic keying that we're doing, and we want to get all the camp A devices on that, and then this one we want all the camp B devices. And so that's now taking like a KV that's stored in the cloud, and it's like demuxing them is what we call them. We're filtering down and replicating those keys so that all of those keys could be read. And so that's kind of a really nice way to go about doing it, is that these things can have configuration updates from the cloud, but they can also go offline, and like the microcontrollers, if they're booting back up and want to do a get to that KV, that's still all going to work because they're not relying on the connectivity from the cloud. It's just kind of a augmentation or a way to get updates. Similarly, you can do very much the same thing with streams, with events up. And so maybe the initial stream lives here inside of the summer camp, and you can take you can basically source multiple streams. So I'm going to just say source, and this is getting messy very quickly, but I'm going to say I want to source everything from stream, from camp A and camp B. Maybe these are metrics, maybe this is telemetry or whatever. And those are automatically just going to be, synced up whenever they can, whenever they have connectivity to be able to do that. Obviously, the devil's in the details, but that there's lots of ways to do this, and you could do this today. Like just play with the leaf node configuration and see how it works. But like it's pretty easy to set up. Angela asks, is there a limit to leaf nodes? Like everything, there's always kind of like these inherent limits that come with them. So I would say like try to figure out how to measure your use case. But we have people running hundreds of thousands of leaf nodes. It just takes, figuring out what you're replicating, how much data you're replicating. I wish I had a clear answer, but it's not like the limit is 12 or anything like that. Like hundreds of thousands does work, but it involves, some good design and forethought and measurement and testing. So Don, have you ever kind of thought about doing something like this, or have you played around with leaf nodes much?
Oh yeah. So I'm actually my day job, apart from doing these silly things, is I'm building a startup, and part of that startup is that I capture metadata from my clients that are running NATS clusters. So basically I look what data is going on, and I basically store the configuration pretty much as you explained over here, like it's in a central cluster and they are running leaf nodes. And then if they, for example, create their Bentos processing, they would do that in the central environment, which is then being pushed towards the leaf nodes, and then it's being executed over there. So yeah, I'm actually using that already.
Yeah, that's a great point. Benthos is a great example of something that like, and I'm sure you and I have talked about this a little bit too, but like that it's when I immediately saw Benthos, I was like, oh, this is all just config based. It's like this could make for a really cool like serverless, construct with NATS KV. And then you bring leaf nodes into the picture, and it makes a lot of sense because Benthos can, generally go into, smaller places, if especially if you build it, with limited components. You can, theoretically see that like, yeah, running Benthos at the edge or in different locations on site, anything with like distribution like a leaf node would have, it makes a lot of sense why you would want something like that.
Yeah, indeed.
Very, very cool. Awesome. Well, I think we are at almost about time. I'm going to try to answer a couple more questions that came in. Charles elaborates by saying, one piece of the solution you're trying to build is liveness, detecting when we made a request that no workers are subscribed to answer. One possible approach would be use the KV store or stream hierarchy to which workers occasionally publish information about what work they're doing. Another design factor is that I'm caching results so we don't rerun requests. Yeah. Absolutely, Charles. Like there's a lot of devil in the details when it comes to building a work queue, and it's funny how many people come to me and are like, "We want to build a work queue," and I was like, "Well, what do you mean by that?" Because it seems like something that sounds obvious, but there's a lot of devil in the details of what expectations there are. And I know there's going to be some more work put into improving like just the work queue semantics in general in future updates of the NAT server. Like that's a constant discussion we're having. So hopefully we can bring more features that can kind of make that more clear. But I agree, like that there might be some room for like just having a reference architecture and some opinions that we have, because there are like a lot of primitives you can interact with to make the work queue better. And it's just a matter of like pointing those out and using them in that way. Um, Okay, and then Zach asked, can a single KV store have subjects that are actually separate streams? For example, global KV, where you have all identities but contains a personal data subject that might be stored physically in separate regions. Not really. Like I've seen people use KVs to like point to other streams, like kind of act as pointers, but it's not like you can like merge all those. Under the hood, a KV is technically a stream. So I wonder what safeguards NATS even has around doing some like weird, crazy stuff with it, with regards to like sourcing specifically. But yeah, right now there's not like this idea of like embedding a stream inside of a KV. But you could certainly like point to certain either sequence numbers or subjects or things like that inside of a stream, and then have your clients or inside of a KV and have your clients kind of like fill in the gaps, if that makes sense. Okay, I think that's about it. Oh, we got one more question. We use NAC with delay in a work queue, and we set our max delivery super high so we can continually re-queue into a work queue. Oh yeah, so Smart MMO just said something very kind of similar to what we were talking about, and literally I just got off a call where we were talking about introducing like, we have the machinery there, this idea of NAC with delay for work queues, which is basically saying, hey, I don't want to process this now. I want to process it in, X minutes or whatever. Right now, that's only available if a client receives it. But we were just talking about, oh, well, it wouldn't be that hard if we really wanted to say, hey, publish this message. And also like it comes with a delay. And so we just, the NAT server will just deliver that, with that delay, which I know is a super common pattern in work queues. So I think that's something that will hopefully come in a future version of the server. Well, that about does it with our time. Don, thanks so much for joining us. This was a great chat. I really enjoyed hearing your perspective on things. And I love what you're doing with Benthos, with like the LED stuff. It's cool because it's like you were describing before. It's like it's kind of stuff that would be really hard to do otherwise, and you're able to do it like by yourself, which is super cool.
Yeah, and thank you for having me over here. It was yeah, it's great technology. it makes you rethink a lot of things, which is a good thing, I think.
Yeah. Awesome. Well, thanks for joining us, and everybody else, thanks for joining. We'll see everybody next week, and we'll chat more about blog posts, maybe even get a few more folks on. Hope this was fun and informative, and we will see you next week.